Howdy, howdy, Dave Staublin here, and we're going to do some good math. Today we are going to do a review of algebraic properties and then use those to simplify variable expressions by combining like terms. Oh my goodness, that sounds horrible. But it's not really so bad. It just has a lot of vocabulary in it. But I think once you see it, you're going to say, I know all about this. So here we go. Let's review 4 properties that are very useful. The first is called the commutative property, and this applies to both addition and multiplication. And so, for example, if you have 6 plus 4, it's the same as 4 plus 6. That's the addition commutative property. If you had 6 times 4, it's equal to 4 times 6. All this says is that the order of adding or the order of multiplication for two numbers doesn't matter. Now, that's arithmetic. Here's what algebra looks like. A plus B is the same as B plus A. And A times B is the same as B times A. All right, next property is associative property. And for arithmetic, it looks like this. If you are adding 3 numbers, it doesn't matter which 2 you add first. So if you add 2 plus 3 first and then add 4, it's the same as adding 3 plus 4 and then adding 2. And the same applies for multiplication. You can multiply the 2 times the 3 first, or you can multiply the 3 times the 4 first, and you'll get the same answer. That's associative. And that's arithmetic. From an algebra standpoint, it looks like this. If you had A plus B plus C, it's equal to A plus B plus C, and it doesn't matter if you add the AB first or the BC first. And the same holds for multiplication. You can multiply the A and the B first or the B and the C first. All right, let's keep rolling on. I hope these are familiar to you. The next is what are called identity properties. And these are going to seem kind of silly, but here's how it works. For arithmetic and for addition, if you have a number and you add 0 to it, you get the same number. And if you have a number and you multiply it by 1, you get the same number. And the same works for algebra. If you have a variable and you add 0 to it, you get the same variable back. And if you have a variable and you multiply by 1, you get the same variable back. All right, last property is distributive property. And it works like this. For arithmetic, if you had something like 3 plus 4 in parentheses, and in front of the parentheses you are multiplying by 2. This is the same as taking this 2 and distributing it to both numbers inside the parentheses. So it's the same as 2 times 3, and then the plus sign, and then 2 times 4. Let's check this out doing our order of operations. On the left side, we'd have 7 inside the parentheses, and then times 2, which gives 14. Over here, we would have 6 plus 8, and if we add those, we get 14. So that shows how distributive works. Now, from an algebra standpoint, it looks like this. if you have B plus C inside the parentheses and then A outside, we're going to take this A and we're going to distribute it inside. So it's the same as A times B and then the plus sign and then A times C. Okay, so those are the properties that we are going to use to do the following. We are going to simplify variable expressions by combining like terms. Okay, so let me show you how this works. Let's say that we have 3 chocolate chip cookies, and over here we have 4 chocolate chip cookies. How many chocolate chip cookies do we have altogether? Well, we have 3 plus 4. We have 7 chocolate chip cookies. Now, this 3 and this 4 and the 7 are called the constant. In this case, the cookies are the variables. We could apply the same concept to algebra. Let's say that we had 3 x's and we had 4 x's and we wanted to find out how many we have altogether. Well, these are the variables and they are alike. So we say this term and this term are like terms. And then we add the coefficients. How many total x's do we have? 3 plus 4 is 7. Okay? Now, let's do something that's a little more complicated. Let's say we have something that looks like this. 6 plus 2a minus 4 plus 2a. Okay? Now, I see that this term has an a and this term has an a, so those are like terms. So I'm going to use commutative property and switch things around, and I'm just going to write 2a plus 2a. Now, see the 6? It doesn't have any variable with it, and there's no sign in front, so it's positive, so I'm just going to write that there. And this 4 is a constant. It doesn't have any variable with it, so I'm going to write that there. And now we can combine the like terms. These are alike because they both have a's, so 2 plus 2 is 4a. And these are alike because they're just plain numbers with no variables, so 6 minus 4 is a positive 2. And we simplified. Let's do another one. Let's say that we have 3 parentheses x plus 1. Now, what do we do with this? Well, I see that we have a 3 that's times all this stuff in the parentheses. Now, inside the parentheses, can we add these together? Well, the answer is no, because they're not like terms. This is a variable. There's no number in front, so it's a 1. And then this is a number without a variable. So these are not like terms. We can't add them together. But we can use distributive property to take this 3 and distribute it to each of these 2 terms. So this is the same as 3 times 1x, and then the plus sign, and 3 times 1. And so 3 times 1 is 3 x's, and then 3 times 1 is 3. And now we have simplified by combining like terms. Let's do a couple more examples. Okay, we're getting a little harder. Let's say we have 2 times 3w plus y minus w plus y. All right, so here's what I'm going to suggest to you. Anytime you have these parentheses here, look inside the parentheses. Are there like terms there? Well, no, this is w and this is y. There's no number in front, so it's a 1. And so, since we can't combine those, let's distribute this 2 inside the parentheses. And I'm going to skip a step. I'm just going to use it in my head. 2 times 3 is 6w. And we have a plus sign. 2 times 1 is 2y. And then we have minus a w. And since there's no number in front, it's a 1. And then we have plus a y. And since there's no number in front, it's a 1. And now we can combine like terms. Now, again, I'm going to skip a step here, and I'm just going to go through and identify all the like terms. And I'm going to do them in alphabetical order. So I'm going to start with the w's. There's a positive 6w and a negative 1w. So 6 minus 1 is 5w's. And then we have a plus 2y and a plus 1y. So 2 plus 1 is positive 3y. And we have combined like terms. All right, let's do one more. Let's do 6x minus 4 times 2x minus m. Okay? So I'm seeing we got an x term. We have this 4 times the stuff in parentheses. So let's look inside the parentheses first. Are those like terms? We've got an x, we've got an m. They are not alike. So let's distribute this number in front of the parentheses to both these terms. Now here is the most common mistake that young mathematicians make. What we have to do is we have to consider what this number is. It's not 4, it's negative 4. Okay? So we have to distribute this negative 4 inside the parentheses. The other thing that we have to do is we have to do this in order. So I'm going to take the 6x and I'm going to write it over here, 6x. And now I'm going to distribute this. Negative 4 times 2x is negative 8x. And negative 4 times negative m. All right, negative times negative is positive. And then we got the 4m. And now we can combine like terms, and we should do it in alphabetical order. So the m's come first. We'll do a little commutative property. So positive 4m. So we've done that. And now these two are like terms. So 6x minus 8x. 6 minus 8 is negative 2x. And so we have combined like terms. All right, so that was a lot of material very fast. But try this. On page 78 in your textbook, this is chapter 2, section 3. I think that you can do 11 through 16 and 21 to 31. Try those. I'll send you the answer key. Do a problem, check the answer. Do a problem, check the answer, so that you don't practice mistakes. As soon as you figure something that's not going right, check the answer key, figure it out, and if you can't do that, message me and we'll work it out together. All right, there it is. Have a good one. Do good math.